Hello students, welcome to Time. In our previous session, we have discussed about the various aspects of language of chemistry, that is naming of various substances and deriving formulae of different types of compounds and all. Now in this session, let us see how we will be able to answer the questions related to language of chemistry. Fine. First, let us go into the test your basics section of the exercise. So these are fill in the blanks questions. Iron can exhibit dash and dash valencies. You know that iron can exhibit variable valencies. It is a transition metal. It can exhibit variable valencies. So let us see configuration of iron. Atomic number is 26. Therefore, configuration can be written as 2, 8, 14, 2. From this atom, it can lose 2 electrons to give Fe plus 2 ion. It can lose 2 electrons from valence shell and can give Fe plus 2 ion. But an electron from penultimate shell also can be lost, thereby forming Fe plus 3 ion. Fine. Therefore, iron can exhibit plus 2 and plus 3 valencies. Binary compounds get dash suffix. What are binary compounds? We have learnt that binary compounds are those compounds which possess 2 elements as the constituent elements. It can be a metal and a non-metal, or it can be 2 non-metals also. So what suffix do they get? For example, if you are taking metal and non-metal, if you are taking sodium and chlorine, fine, the compound is named as sodium chloride. So this is getting IDE suffix. If you are taking metal and non-metal, the well-known compound CO2, if we take, what is the name of this? It is named as carbon dioxide. IDE suffix. Any binary compound, it gets IDE suffix. IDE. Fine. The formula of a divalent metal phosphate is, see, divalent metal can be represented as M plus 2. Now what's the formula of phosphate radical? Phosphate is obtained from a tribasic acid H3PO4. So it forms a trivalent ion. This is phosphate ion. PO4 minus 3. Now, if we write the formula by crisscross method, 3, 2, after exchange, fine. Then this becomes a subscript here and this becomes a subscript. M3PO4 taken twice is the formula of the metal phosphate. Fine. Now, these are multiple choice type of questions. So let us see. HXO2 is the formula of us acid of a nonmetal X. The formula of peracid of the same nonmetal is, we have seen, just you can recollect, a nonmetal can form us acid and ic acid. Us acid is the one which has less number of oxygen atoms. So here HXO2 is the formula of us acid. Fine. So what should be the formula of ic acid? It could be HXO3. Ic acid. Fine. And some non-metals form other oxyacids also, hypoacids and peracids. Hypoacid, if we take, it has less number of oxygens than the acid. Then we give hypo prefix. And peracids are those acids which contain more number of oxygen atoms than ic acid. So we add per prefix. Fine. So this HXO4 is the formula of the peracid of the same non-metal. So we go with choice 2. Right? Number of ammonium radicals in the formula of ammonium phosphate. So if we have to know the number of radicals, we need to write the formula of the compound. How do we derive the formula of ammonium phosphate? Formula of ammonium radical is NH4 plus. Phosphate radical is PO4 minus 3. This is 1, this is 3. Fine. If we crisscross it, 3 and 1. Now, how do we write the formula? NH4, because it is 3, we write 3 as the subscript. 3PO4. Means how many radicals does it possess? So 3 NH4 plus radicals and 1 phosphate radical. So number of ammonium radicals in the formula of ammonium phosphate is 3. So we go with choice 3. The ratio of total number of atoms in zinc phosphide and ammonium bicarbonate is total number of atoms. You have to find the ratio between zinc phosphide and ammonium bicarbonate. So let us derive the formula of zinc phosphide and ammonium bicarbonate. Zinc phosphide contains, then phosphide is P minus 3. Now 2, 3. If we crisscross the valencies, you get 3 and 2. So how do we write the formula? Zn3 P2. Fine. Now let us see ammonium bicarbonate. NH4 plus HCO3 minus. This is minus 1. Fine. Both are having valency 1. Therefore, if we crisscross also, we get the same valency. The formula is NH4 HCO3. Right? So, number of atoms in zinc phosphide and ammonium bicarbonate. Zinc phosphide is 3 zinc and 2 phosphorus atoms. So, 5 atoms are there in a molecule of zinc phosphide. Ammonium bicarbonate, if you count 10 atoms. 1 nitrogen, 5 hydrogens, 1 carbon, 3 oxygens. So, the ratio of number of atoms should be 5 is to 10. It is nothing but 1 is to 2. We go with choice 4. Which are the following non-metals forms only one oxyacid? Let us see the options. You know that carbon can form oxyacid H2CO. It cannot form any other oxyacid. This is the only oxyacid that carbon gives. Sulfur can give sulfurous acid, sulfuric acid. Nitrogen can give nitrous acid, nitric acid. Chlorine can give 2 more oxyacids, hypochlorous acid, perchloric acid also. Therefore, carbon is the only non-metal which forms one oxyacid, right? So we go with choice 1. Arrange the following salts in the ascending order of oxygen atoms. So if you have to know the number of oxygen atoms, we need to know the formulae. So let us write the formulae of these salts. Magnesium bisulfite. So how do we write the formula? Magnesium is Mg plus 2. Bisulfite is HSO3 minus. Right? 2, 1. If you do crisscrossing, you will get 1, 2. HSO3 taken twice, right? So let me write the formula here. MgHSO3 taken twice. Fine. Sodium sulfate. Sodium gives monovalent ion Na plus. Sulfate is bivalent ion SO4 minus 2. Okay, 1, 2. After crisscrossing, you can write Na2SO4. So the formula of sodium sulfate is Na2SO4. Right. Aluminium carbonate. Aluminium is Al plus 3. Carbonate is CO3 minus 2. 3, 2. If you crisscross these valencies, you will get 2, 3. Now, we write the formula as Al2CO3 taken thrice. Right. So, let us write here Al2CO3 taken thrice. Ammonium nitrite. Ammonium is NH4 plus. Nitrite is NO2 minus because it is formed from nitrous acid. Because both are monovalent, you just write the formula as NH4 and O2. So let us write here NH4. So let us write here NH4 NO2. Right? Now just count the number of oxygen atoms. 3 2s are 6. This is having 6 oxygen atoms. And here you can see 4 oxygen atoms. And here 3 3s are 9 oxygen atoms. And in this case 2 oxygen atoms. So we need to write them in the ascending order. So which one will come first? D. D. After that B. After that A. After that D, B, A, C. We go with choice 1. Fine, children. So we have done our test your basics section. Those are all simple questions and they are objective questions. Now let us go into the subjective part of the exercise. Fine. So first we see the knowledge based questions. These are also simple questions but subjective questions. Write the names and formulae of oxy acids of chlorine. So I have already told you that chlorine can form 4 oxy acids. HClO2 is chlorous acid. We have to write the names also. Chlorous acid. Then chloric acid. HClO3. Then hypochlorous acid. Hypochlorous acid formula should be HOCl or HClO. Then perchloric acid. These are the 4 oxy acids formed by chlorine. Their formula and the names. Let's go to the next question. Some metals show variable valency. Write the formulae for the ions formed by the following metals along with names. So mercury, if you are taking, it forms 2 ions, Hg plus and then Hg plus 2. Okay, this is mercurous. This is mercuric. or you can write it as mercury 1, Roman numeral 1 in brackets, mercury 2. In both the ways you can write. Gold symbol is Au, therefore it forms Au plus and then Au plus 3. This is Aurus, this is auric. Copper, if you are taking, it forms two ions, Cu plus cuprous, Cu plus 2 cupric. Fine. Right. Lead if you take, it can give Pb plus 2 and then Pb plus 4 ions. Pb plus 2 is plumbous. Pb plus 2 is plumbous. You know that the lower valency ion gets us suffix. Then the higher valency ion gets ic suffix. So Pb plus 4 is plumbic. Now iron. It forms Fe plus 2 and then Fe plus 3. Obviously Fe plus 2 is ferrous, Fe plus 2 is ferric. Right? Write the formulae for the following radicals. Peroxide radical. Peroxide radical is O2 minus 2. You have to be careful. O minus 2 is oxide. Okay. O2 minus 2 is peroxide because there will be a linkage bond between two oxygen atoms. So the entire thing is, species is single radical. This is peroxide. Dihydrogen phosphate. So you know that H3PO4 is phosphoric acid. Dihydrogen means two hydrogens should be there. So one hydrogen is lost. So you get H2PO4 minus. This is called dihydrogen phosphate. So H2PO4 minus. Permanganate. Permanganate is MnO4 minus. Then silicate. SiO3 minus 2. Zincate. ZnO2 minus 2. Bisulfite. HSO3 minus. Fine. Hypochlorite. So you know that the formula of hypochlorous acid is HOCl. So if you remove one H plus, you will get OCl minus. That is hypochlorite. OCl minus is hypochlorite. Right? Define valency with respect to hydrogen and oxygen. This is a simple question. So how do you define valency with respect to hydrogen? It's nothing but the number of hydrogen atoms with which one atom of an element can combine. If you are considering, say suppose hydrogen sulfide. So one atom of sulfur combines with two atoms of hydrogen. So valency of sulfur is 2. Now with respect to oxygen, if we take, valency is defined as double the number of oxygen atoms with which one atom of an element can combine. For example, if we are taking sulfur dioxide, one atom of sulfur combines with two atoms of oxygen. Therefore, valency of sulfur is 4. If we consider sulfur trioxide, then the valency of sulfur becomes 6. Right? Now distinguish between ion and radical. Give examples. See, ion is formed when an atom gains or loses electrons. One or more electrons. For example, if we are taking calcium, it loses 2 electrons to form Ca plus 2 ion. So it's called cation. If we take suppose sulfur, it gains 2 electrons and forms S minus 2 ion. These are the ions. What is a radical? When a group of atoms together, that means atoms are bonded to each other, together they lose or gain one or more electrons, you call it a radical. To put it in another way, it can be called polyatomic ion. Radical can also be called polyatomic ion. Say suppose you are taking bicarbonate, let's see, O3 minus, or carbonate. See, here there are 3 elements. Here there are 2 elements. Or you take positive one, NH4 plus. You have 2 elements, PO4 minus. You have 2 elements here like this way. These are called radicals. Fine. These are the examples. You can give any example. Like you can take dichromate, manganate. Let's move forward to a slightly higher level of questions which require better comprehension. So that's why we call them understanding based questions. Descriptions of some radicals are given below. Write the names and formulae of the compound formed with Fe plus 2 ion. Radical with 1 phosphorus atom and 4 oxygen atoms. So what should be the radical here? PO4 minus 3 is the radical. Now, if we take Fe plus 2 and PO4 minus 3, how do we write the formula? Fe plus 2, PO4 minus 3. 2, 3, if we crisscross, we get 3 here and 2 here. When we write the formula, it is Fe3, PO4 taken twice. So this should be the formula of the compound of phosphate, this radical with Fe plus 2 ion. Radical with 1 hydrogen atom, 1 sulfur atom and 4 oxygen atoms. Means you can tell 1 hydrogen, 1 sulfur and then 4 oxygens. So you can understand that it is derived from sulfuric acid. After it loses 1 H plus. Therefore it gets minus 1. It's a monovalent radical. Now if we see the formula with Fe plus 2 ion, Fe plus 2 and then HSO4 minus. This is 2, this is 1. So if we crisscross it, 1 and 2, Fe, HSO4, taken twice. Right? Radical with 1 nitrogen atom and 2 oxygen atoms. 1 nitrogen and 2 oxygen atoms, that is NO2 minus. Because this is obtained from nitrous acid. Fe plus 2, NO2 minus. Fe plus 2. So 2 here, 1 here. If we crisscross it, we get 1 here, 2 here. So Fe, NO2 taken twice. Fine. We have written the formulae. Names also we have to write. Not only formulae. So what is the name of this? It is ferrous ion. So for all of them we get ferrous in the first part. Then phosphate. This is ferrous phosphate, or you can also write it in another way, that is iron to phosphate. This is ferrous hydrogen sulfate. Or ferrous bisulfate also, or iron to hydrogen sulfate. In both the ways you can write. So this is ferrous nitrite, because it is obtained from nitrous acid. Ferrous nitrite or iron to nitrite. Identify the incorrect formulae among the following by giving proper justification. So you need to identify the incorrect formulae. So let us see BaNO2. Whether it is correct or not, you will be able to know if we write the formulae. Barium, you know that it is second group element, so it forms +2 ion. NO2 minus, because it is derived from HNO2. After losing one H plus, it gives the monovalent radical. 2, 1. Okay. BaNO2 taken twice. Because this is +2, this has to be -2. So this formula is wrong. Right? Now KSO4 they have given. Potassium is K plus because it is first group element, and then SO4 -2. This is from sulfuric acid after losing both the hydrogens. So now this is 1, this is 2. Therefore this becomes 2, this becomes 1. So you write K2SO4. It should be the formula of potassium sulfate. But here it is written KSO4. Therefore it is wrong. Now aluminium phosphide. Aluminium is Al plus 3. Phosphide is P minus 3. Because it has 5 electrons in the valence shell, it takes 3 electrons to complete its octet. So this is 3 and 3. Therefore we get 1 and 1. It is aluminium phosphide. Now, this is a correct formula. Now, zinc sulfite, Zn plus 2, SO3 minus 2, because it is obtained from H2SO3. So, both are 2. Therefore, it gets cancelled anyway. We will write it as ZnSO3. Now calcium bisulfite, Ca plus 2, HSO3 minus 2, 1, 1, 2, Ca, HSO3 taken twice. So this is correct formula, and this is again a wrong formula. So identify the incorrect formulae. So this A is incorrect, B is incorrect, E is also incorrect. Fine. Complete the following table. Here name, formula and total number of atoms are given. We need to complete the table. Any one column, entry in one column is given. Seeing that, you need to fill the other columns. Now let us take the first one, PbO2. Actually, you can take the opposite of crisscross method. What happens, this 2 goes here, okay, this 1 comes here, right? But oxide should not be 1, it should be 2. That means it should also be doubled. So it has Pb plus 4 ion and then O minus 2. So if we write the formula, we can just check like this. 2 and 4. So they can be made 1 and 2 by dividing by 2. Okay. So therefore you get PbO2. So what is the name? Pb plus 4 is plumbic. So we can write plumbic oxide. We can also write it as lead 4 oxide. The total number of atoms, you can see 2 atoms of oxygen, 1 atom of lead. So totally 3 atoms are there. Now sodium peroxide. Sodium, you already know that it is Na plus. Peroxide, we have seen it is O2 minus 2. So 1 and 2, 2 and 1. That means Na2O2. This 2 you should not forget, right? Na2O2 is the formula of sodium peroxide. So how many atoms are there? 4. 2 sodium and 2 oxygen. Potassium chlorate. Potassium is K plus. Chlorate is ClO3 minus. So both are having valency 1. So the formula should be KClO3. KClO3. So how many atoms are there? 5. Then coming to Na2HPO4, formula is given. So you have 2 sodiums. So you can write it as disodium hydrogen phosphate. Disodium hydrogen phosphate or biphosphate. Disodium biphosphate. Then phosphorus acid. Total number of atoms 2 plus 1 3, 3 plus 1 4, 4 plus 4 8. 8 atoms are there. Phosphorus acid. It should be H3PO3 because phosphorus forms H3PO3 and H3PO4. So this is phosphorus, this is phosphoric. So how many atoms are there? 7. Total number of atoms is 7. Per molecule, you mean. Write the formula of the compounds formed by the set of elements with following atomic numbers. Let us see each set. Z is equal to 6 and Z is equal to 8. You know that Z is equal to 6 corresponds to carbon, Z is equal to 8 corresponds to oxygen. So, you get CO, CO2. Carbon monoxide, carbon dioxide. Fine. Z is equal to 13 and Z is equal to 16. This is aluminium and this is sulfur. Okay. So aluminium forms Al plus 3 ion. Sulfur forms S minus 2 ion. Therefore the formula should be Al2S3. Fine. Aluminium sulfide. Z is equal to 12 and Z is equal to 15. So this should be magnesium and this should be phosphorus. So magnesium is Mg plus 2. Phosphorus forms phosphide, that is P minus 3. Magnesium forms Mg plus 2. Magnesium forms Mg plus 2. Magnesium forms Mg plus 2. Phosphorus forms P minus 3. 2 and 3. This is magnesium phosphide. So what should be the formula? Mg3p2. So this is magnesium phosphide. Right. Z is equal to 20 and Z is equal to 7. This is calcium. This is nitrogen. Calcium is Ca plus 2. Calcium gives Ca plus 2. Calcium forms Ca plus 2. Nitrogen forms N minus 3. If you crisscross and write, it becomes Ca3N2. Calcium nitride. So this is how you write the formulae. Just identify the elements, then you will be able to know which ion it is forming. You can also write the electronic configuration if you are not sure about the ion that is formed. Then also it will give you an indication as to which ion that element can form. Right? Now, let's move on to the most interesting part of the exercise, that is application based questions. A metal M forms a compound with a non-metal with atomic number 8, and the ratio of non-metal to total number of atoms is 1:3. Derive the formulae of the following compounds of the succeeding element of M. Hydrogen phosphate. Like this way. Just let us try to identify the element. A metal M forms a compound with a non-metal with atomic number 8. Non-metal with atomic number 8 should be oxygen. Ratio of non-metal to total number of atoms is 1:3. One oxygen, one non-metal means one oxygen atom is there, and metal atom should be 2 because total number of atoms is 3. So you can write it as M2O is the formula. So if you have to derive the formula of the compounds, you should know the valency of the metal. So from the formula you can know that it is M plus, monovalent. Now you see hydrogen phosphate. So M plus and then HPO4 minus 2. So the formula of the compound should be M2 HPO4 M2 HPO4 should be the formula. Right? Now, bicarbonate M plus and then HCO3 minus. It should be M HCO3. Silicate M plus SiO3 minus 2. M2 SiO3. Okay. Nitride. It should be M plus N minus 3. Nitride is N minus 3. That means M3N should be the formula. Hope you have understood how to write the formulae. Now, A metal A forms an oxide of the formula A2O3. Identify the group to which it belongs in the periodic table. Assuming that the atom has only one incomplete shell, identify the element. A metal A forms an oxide of the formula A2O3. Identify the group to which it belongs in the periodic table. So let us see the first part of the question. A2O3. That means it should have A plus 3 and then O minus 2. Okay. It is forming plus 3 ion. Means there should be 3 electrons in the valence shell. So which group elements possess 3 electrons in the valence shells of their atoms? Yes, it should be 13th group or 3A group. Both the notations I am telling you. Then, so this we have identified. Identify the group. Fine. Assuming that the atom has only one incomplete shell, identify the element. So it is a metal. Okay. Therefore, 13th group elements, if you remember, they are boron, aluminium. So like this way it goes. So boron is not a metal, so it's a non-metal. So we will avoid it. Aluminium, what's the configuration of aluminium? It is 283. Fine. So this is having one incomplete shell, third shell. So it could be aluminium. Similarly, gallium, if you take, what is the configuration of gallium? 2, 8, 18, 3. Okay. So here also only one incomplete shell. Fourth shell is the incomplete shell. This is complete, this is complete, this is complete. So it could be either aluminium or gallium. Identify the element means it should be either aluminium or. Write the formulae of the following compounds of the same metal. Salt of the higher oxy acid of sulfur. Sulfur forms two oxy acids, sulfurous acid and sulfuric acid. Higher oxy acid is sulfuric acid. Fine. That means it is H2SO4. So if you are taking A plus 3, metal A, so that's why I am taking like this. And sulfuric acid, can give 2 ions, SO4 minus 2, HSO4 minus. Okay. Now both the salts it can form A plus 3. That means general formula. A they have given, no? So that is why. And then SO4 minus 2. Okay. So you get A2 SO4 taken thrice. With HSO4 minus also it can form A plus 3 and HSO4 minus. So you get A HSO4 taken thrice. Right. Now compound with the non-metal belonging to second period and 15th group. So non-metal belonging to second period and 15th group is nitrogen. So A plus 3. So what is the radical formed from nitrogen? N minus 3. A plus 3 and N minus 3. Both are 3. Therefore, AN should be the formula. Salt of the oxyacid of a non-metal which forms only one oxyacid. So I have already told you, non-metal which forms only one oxyacid is carbon. Okay. What is the formula of that oxyacid? H2CO3. It can also form two radicals, CO3 minus 2, HCO3 minus. Right. So this is A plus 3. CO3 minus 2 means you get A2CO3 taken thrice. If we take HCO3 minus A plus 3 HCO3 minus. If we write like this, you don't get confused. A HCO3 taken thrice. Fine. So this is the way we need to write all the probable formulae. If we write, it is like a practice for you. Salt with a radical formed by the ic acid of phosphorus in its first step of ionization. Ic acid of phosphorus means H3PO4. First step of ionization. How does it ionize? H plus H2PO4 minus A plus 3 H2PO4 minus. A H2PO4 thrice. Right. This is the way you need to write the formulae. So all the probable formulae if we write, you will get some practice of writing the formulae. Now that we have finished application based questions also, you must be having some strong hold over the concepts. So now let's see a couple of practice questions. The formulae of manganic sulfate and calcium ferrothiocyanate are given. Find out the formula of manganic ferrothiocyanate and mention the ratio of number of atoms of manganese and sulfur. Find out the formula of manganic ferrothiocyanate and mention the ratio of number of atoms of manganese and sulfur. Manganic sulfate. This is the formula. From this formula, we should be able to know what is the manganic ion. Mn2SO4 taken thrice. So this 3 goes here, 2 goes here. Therefore, you can understand that it is the salt of Mn plus 3 ion. So this is the manganic ion. Fine. Calcium ferrothiocyanate. From this we have to analyze the formula of the negative radical. Ca2Fe CnS6. See here, this 2 goes here. 6, you don't get confused. 6 should be here. And this is only one time, so this 1 comes here. But you know that calcium forms plus 2 ion, not plus 1 ion. Therefore, it should be doubled. So this 2 becomes 4, this 1 becomes 2. So Ca plus 2. Because it becomes plus 2, it should become minus 4. And then FeCNS 6 minus 4. So this is a ferrothiocyanate ion. Now we need to write manganic ferrothiocyanate. So manganic ion we are having here. So Mn plus 3 and then FeCNS6 minus 4. Okay. So if we crisscross it 3, 4. So if we crisscross it, it becomes 4 and 3. So we write the formula. Now we write the formula as Mn4 FeCNS6 3. Because here 3 is the subscript. This is the formula. And mention the ratio of number of atoms of manganese and sulfur. So how many manganese atoms are there? 4. How many sulfur atoms are there? See, here there is a bracket, so 6. Again another bracket, 3. 6 3s are 18. 4 is to 18. This can be simplified as 2 is to 9. So the ratio of number of atoms of manganese and sulfur should be 2 is to 9. Right? The formulae of some compounds are given below. Write the formulae of the corresponding cation and anion. Also mention the names of the negative radicals. M2O2, M plus. It should be M plus O2 minus 2. Otherwise, if it is M plus, it should be written as M2O. If it is M plus 2, it should be written as MO. M2O2 means it should be peroxide. Therefore, we write it as M plus and O2 minus 2. So, this is the negative radical. Name of the negative radical here is peroxide. Now, MHSO3 taken twice. So, here you can easily write this 2 goes here. Therefore, it will give you M plus 2. Okay. HSO3 minus. This is a monovalent radical. So, what is the name of this? Hydrogen sulfide. You also call it bisulfite. M3PO4 twice. This 2 goes here, 3 comes here. Therefore, it should be M plus 2 PO4 minus 3. So, what is the name of the negative radical here? Phosphate. M2Cr2O7. This 2 goes here. So, it should be 1. M plus Cr2O7 minus 2. So, this is a single radical. Because here there is no bracket and there is no subscript, you have to consider this as one radical. Therefore, it will be Cr2O7 minus 2 is dichromate. The name of that radical is dichromate. M2CrO4 taken thrice. This 2 goes here, 3 comes here. Therefore, M plus 3 CrO4 minus 2. CrO4 minus 2 is chromate. So, this is how you need to write the formulae when the radicals or names are given. Similarly, when formulae are given, you can write the radicals. You can derive the radicals the opposite way. Fine. Hope you have clearly understood the concepts and you have got some practice of writing the formulae also, which is very much required for the later topics what we are going to deal with in this chapter, that is stoichiometry and the calculations related to stoichiometry, calculations related to chemical equations and all. Okay children, I'll wind up the session here. Thank you.